All right, and x equals approximately what? Let's round it to the nearest foot. Grace, what did you get?
Here, wait, give me a second. I don't know. Do you have to put the sign into like the inverse?
No.
Or no?
Mm-mm.
I got 0.75.
All right, are you using, what's your calculator look like?
I'm using the same one as you.
As me? Okay, like this?
Yeah.
All right, type in 6 divided by 8, and then sign, equals.
Okay, 43.1.
Yep, so approximately 43 feet.
I was doing sign
Wait.
for 8.
Oh, sorry, you were doing,
Yeah. It's okay.
say that again, Grace, you were doing?
I did 6 divided by sign of 8.
Oh, instead of 8, 9?
Yeah.
Okay, so, yeah. You have to hit, on this kind of calculator, that's why, I mean, you just have to get used to your calculator. You hit 8 and then sign, and that'll give you the sign of it. Yeah.
Mine just tells me error.
All right. Are you using the one on the computer?
Yes.
All right. So let me pull that one up and present, and I'll see what's going on. Yeah, because every calculator is different. Can you see my screen, Colby?
1 second. Yes.
Okay, so I'm going to type in this one, 6 divided by, for yours, I think you have to hit sign 8. Type it in like that and see if that works.
I tried that and I got 6.
Hmm. 6, and we're in degrees. 6 divided by, Oh, there it went. Try it again, Colby. I don't know what happened. Maybe I was in radians. I think I was not in degrees. Click on degrees.
Oh, there we go.
Got it? All right. I think it was in radians. Okay. So I would like us to try a few more like that. So, but we're going to look at example 3 on page 610. Okay. This one is using 2 angles of elevation or depression. Okay, so let's look at this one. It says to estimate the height of a tree she wants removed, Mrs. Long sights the tree's top at a 70-degree angle of elevation. She then steps back 10 meters and sights the top at a 26-degree angle. Do you see how, if you look at the diagram, they're making 2 triangles? If Mrs. Long's line of sight is 1.7 meters above the ground, how tall is the tree to the nearest meter? So I'm not sure why she wants to know how long tall the tree is. Like I said, this is the problem the geometry kids had last year. Like, why? I don't know. Maybe she's going to cut it down and she doesn't want it to hit the house.
But she's in a clearing.
It does look like a clearing. Maybe the house is like right off the picture. But like Mrs. Palmer has a tree I want removed. I'm just going to call the tree guy, and I'm going to assume he's not going to hit my house with it, and I'm not going to do the angles, but maybe the tree guy has to do the angles so he doesn't hit someone's house. So maybe you guys are going to be the tree guy. So you'll need to know how to do this, okay? But you see there's 2 triangles.
No.
And it says that both triangles, if you say understand, both triangles are right triangles, and the height of the tree is the sum of Mrs. Long's height plus AB. So we have to know that. Since her initial distance from the tree wasn't given, we're going to give that a variable. They called it y. And then she moved 10 feet back, so we knew that was 10. So that whole height is y plus 10. The height of the tree is x plus 1.7 because we're measuring her in meters, right? We use triangle ABC. So we had that 70-degree angle. Tangent of 70 is x over y. And they go through all of the work, which is a lot, and they find out it's about 8 meters. I don't know that we will really do the 2 triangles. I'd like us to get better at doing at least 1 triangle. So let's just look on page 611 at number 1 for now. Lenora wants to build the bike ramp shown. Find the length of the base of the ramp. Okay? So the base is going to be that side that ends with the right triangle. You have a 20-degree angle. You know the height. So I think you guys can do this triangle. Okay, it'll be much like the last one. I'm going to give you like 2 minutes to work on this, and then we'll check our answers together. Okay.
Wait, we're on example
we're
3, right?
well, no, we're doing page 611, number 1.
Oh, that makes more sense.
So it doesn't have the 2 triangles. It's just 1 triangle. Right. This one should be like the one you did last night, and the one we just went over.
That's a long bike ramp.
Find the length of the base. All right. Brian, what did you get?
About 27.5 feet.
Okay, good. What did you do?
10 divided by 20 tan.
Good. Okay. So it was much like the triangle we just did, but this time it's tangent. Okay, opposite over adjacent. And we know the opposite. We didn't know the adjacent. That's what we're looking for, the x right there. Okay, so you do the cross products. X sine 20 equals 10. You have to divide both sides by sine 20. So x equals 10, sorry, not sine, but tan. 10 divided by tangent of 20 degrees. And you get 27.5. Right? Is there anyone who's not getting that with their calculator? You want to take a look? Okay. I want to also look at number 2 because I want us to get practice at drawing the picture if they don't give us one. All right, so let's look at number 2. A baseball fan is seated in the upper deck of a stadium 200 feet away from home plate. If the angle of depression to the field is 62 degrees, at what height is the fan sitting? Okay, so you're going to have to draw a triangle. All right. Does anybody need more time?
No.
Okay, let's do our survey. Let me put up my list and start with who's at the top. Is it always the same? Aristotle, you're up top today. How far?
376 feet.
Okay. Brian?
Wait, I just forgot. I'm gonna redo it real quick.
Okay. Colby?
I got 300. Wow. I got the same thing as Aristotle.
376?
Yeah.
Great.
I got 226.5 feet.
Lily?
376.
Okay.
89.
Okay. I'm gonna hold mine up. Here's my drawing. This is home plate. Okay. We got this person sitting on an upper deck over here, 200 feet away. So this side is 200 feet.
Now I did the 200 feet on the bottom, like
That's what I
on like
did.
the long. Yeah.
Here?
Because he's 200 feet away. Because wouldn't the 200 feet be his line of sight?
No, yes, but yes, that'd be straight to the fan though.
And this is his line of sight. He's sitting up here. He's sitting like up here in an upper deck, it said.
Okay.
So he's 200 feet away. Here's the batter. So this guy's sitting in the stadium 200 feet away. So this is your 200.
Okay.
Okay. And we want to know how high up that is. So I called that X. So here's my right angle. So and if this angle of depression is 62 degrees, remember that we have two parallel lines with a transversal crossing them. So alternate interior angles. This is also 62. Okay. So opposite over hypotenuse. So sine of 62 degrees equals X over 200. And I use my cross products. This time I don't have to, I have just X equals sine of 62 degrees times 200. Okay. I do think these are the worst problems. I always thought so when I was in geometry and trig and physics because of my drawing issues and trying to like imagine when they don't give me the diagram, trying to imagine what that is. Okay. But I want you guys to work on just 4 of these problems tonight. So on the same page, I want you to try 4, 5, 6, and 7. All right, so there's 4 problems, and they would be like this.
Wait, which ones are
A couple of them, they don't have a diagram, so you're going to have to draw one.
So which ones are we doing?
4, 5, 6, 7.
Okay.
Okay? And then we'll meet back tomorrow. If you guys have questions about them, I'll be available 2 to 3, or you can email me. Okay?
Thank you, Mrs. Palmer.
You're welcome. Have a great day, guys.
Thanks, you too.
They
Yeah.
Bye-bye.